Get started. Hello and welcome. We're so glad you're with us today. My name is Sri Gopal, and I'm the Coastal Habitats Program Manager at Ocean Protection Council. And today, along with my colleague, Dr. Adam Marino from California Air Resources Board, I will be co-leading this informational webinar focused on OPC's report on blue carbon data and model assessment in the context of CARB's 2027 scoping plan. I'm also joined today by Dr. Melissa Ward from Windward Sciences and Dr. Kyle Lundberg from CARB. Dr. Ward authored this report and has offered to address questions at the end of the presentation. And Dr. Lundberg has offered to take notes and monitor questions that come into the chat. Thank you so much to both of you. So as several of you are aware, OPC is a cabinet-level state agency charged with protecting, conserving, and maintaining California's ocean and marine resources for the benefit of current and future generations. We were established in 2004 pursuant to the California Ocean Protection Act, and our role in the California government is to recommend policy, lead and promote coordination, seek and leverage funding, and inform government decision-making with sound science. Our position within the state government offers a unique opportunity to connect state agencies, scientists, NGOs, and policymakers to really inform policymaking related to California's coast and ocean. And the Blue Carbon report that we focus on today is one such example of this connection. And the goal with this OPC-funded report was to work with other state agencies, notably CARB, scientists, and stakeholders in the blue carbon space to help lay a foundation for policy on California's coastal wetlands in the context of CARB's 2027 scoping plan. And to get us started off with the why, I invite Dr. Adam Marino to speak on this. Adam, the floor is yours.
Great. Thanks, Sri. Yeah, I'm Dr. Adam Moreno, and I'm the manager of the Nature-Based Strategies section at the California Air Resources Board. And this section leads CARB's work to include natural and working lands into the state's climate strategies and to keep and report the natural and working lands carbon inventory, which tracks progress towards our carbon and climate targets. We also lead CARB's collaboration with other state agencies to develop nature-based solution strategies, such as the nature-based solution targets that the governor announced last April. Next slide. So I'd first like to start by taking a moment to explain how we are thinking about natural and working lands for carbon target setting and tracking. So we categorize all lands in California using this scheme showed here. And this is defined by the Intergovernmental Panel on Climate Change, or IPCC. And CARB tries to be consistent with national and international standards as much as possible. Additionally, all lands within California's borders are included in the state's strategies. So regardless of ownership or even whether climate action has occurred on those lands or not, they're included in what we are considering our strategies and in our inventory. In this way, we are counting the entire carbon balance of the natural carbon cycle. So this is to say, every square inch of vegetation, soil, and water within California's borders are a part of the state's natural and working lands climate strategy. Next slide. In terms of climate, the ultimate objective of the state is to be carbon neutral by 2045. And natural and working lands are now an official part of that equation as shown here. So this is a simple equation with a lot of complexity behind it, and it's how the state is thinking about carbon neutrality. So here you can see carbon neutral is achieved when AB32 greenhouse gas inventory sector emissions, which are those emissions from fossil fuels, dairies, and landfills, plus minus natural and working lands emissions and sequestration, minus any other technological carbon dioxide removal equals or is below 0, then that means we've achieved carbon neutrality. So this equation demonstrates that natural and working lands can be both a source and a sink of GHGs in any given year, or even over longer periods of time. Next slide, please. The first step to developing a statewide climate strategy for natural and working lands is to understand what you have and where it is and how it is currently changing. For this reason, CARB keeps the natural and working lands carbon inventory. On this slide, you can see with the pie chart on the left, the proportion of carbon that exists within each ecosystem in California. You can see that the majority of carbon is in California's forests and shrublands, and that is a relatively small proportion, a relatively small proportion of the carbon stocks are in wetland soils. So the caveat here is that in this figure, only delta wetlands were included because that was the only place at the time of this inventory where sufficient data existed to quantify carbon stocks and stock change. And so you can see also in this slide that we want to know how carbon stocks are changing through time, as demonstrated on the graph on the right. So in this graph, lines that are going down means a loss of carbon from the ecosystem to somewhere else, the atmosphere, for example. You can see some systems are experiencing increases in carbon stocks, like in woody crops and urban forests, while our soils and forests are estimated to be losing carbon. Next slide, please. The next step in developing a statewide climate strategy is to then estimate what will happen in the future and what our options are for changing these outcomes for the better. To accomplish this, every 5 years, CARB develops a scoping plan, which is the state's roadmap for mitigating climate change. The last scoping plan, approved in 2022, was the first to include natural and working lands. The work includes, and this work includes a lot of science and modeling of all ecosystems in California under different future climate and management scenarios. The graph shown here shows the outcome of the scoping plan modeling, along with all of the natural and working land modeling that has ever been done in California by independent researchers. So this graph shows, this graph is showing carbon stock changes relative to 2001 stocks. So anything below that 0 line is a loss of carbon from the ecosystem. That gray shadow shows all of the results from independent research on this topic found through a literature review and meta-analysis that CARB performed. The gray dotted line is the average of all of those independent results, and the solid black line is the average result of the scoping plan modeling under the approved management scenarios. And then the solid blue line is CARB's natural and working land inventory. And so what you can see here is all science is pointing to the fact that California's natural and working lands are likely to lose carbon over the next 20 years. And so our choice is not whether we will lose carbon in these systems or not, it's how we want to lose this carbon, whether it's through drought, drought-induced vegetation mortality and catastrophic wildfires, or through informed management actions and biomass utilization. Next slide, please. So how do coastal wetlands fit into this strategy? Well, as I mentioned, only delta wetlands are currently included in this work, and that is because these systems have been widely studied for many years, and so data and models exist specifically for these wetlands that lend themselves to climate planning. Additionally, the data requirements for wetlands are higher than those for other ecosystems, as we assess both carbon stock changes and methane release. Delta wetlands are facilitated by a network of long-standing flux towers measuring CO2 and methane, mapping efforts to track change, and tailored biogeochemical models. No other wetland has even close to this amount of information, and indeed, few other ecosystems at all can compete with this amount of information. However, as we move outside of the delta to other coastal wetlands, not only is the data sparse, but in some cases, it becomes non-existent. Coastal wetlands are very diverse, and their behavior changes with the many different conditions that exist up and down California's coastline. Because of this diversity, just extrapolating the data from the delta everywhere is not optimal, and in some cases may be misleading. For example, Southern California coastal wetlands in and around LA and San Diego have unique interactions with developed lands, such as susceptibility to sea level rise, altered topography, and transient connections to other water bodies. This changes the dynamics of these systems completely, and there's currently not enough information for us to accurately quantify carbon stocks and how carbon will change in those systems into the future. And so we will not include numbers that do not provide a certain degree of scientific and statistical confidence within the Natural and Working Lands Carbon Inventory or Scoping Plan. The inventory and scoping plan are science-based programs, and for this reason, science and data are required to include systems and carbon pools within California's strategies. Next slide, please. However, California will not wait to take action just because science and data are lacking. Many climate actions exist that we know are beneficial to ecosystems and society that we simply cannot quantify the carbon implications of. For this reason, it's important to remember that in California, the objective of nature-based solutions climate action is not to maximize carbon stocks and sequestration, but rather to enhance the health and resilience of ecosystems and communities, which will lead to more diversified, durable, and sustainable carbon stocks and sequestration rates in the future. Next slide, please. So to this end, California has set the most ambitious range of nature-based solution targets that include all lands in the nation. These targets include many actions that cannot currently be quantified within CARB's scoping plan or inventory. However, this provides guidance on how CARB should work to enhance our capabilities. The actions set in these targets include wildfire fuel reduction, conservation, restoration, as well as sea level rise protection. When you add up all of the acres associated with these targets, it equates to the equivalent of half of California's land area experiencing some climate action by 2045. Next slide, please. This slide shows the targets that are set for wetlands and seagrasses, and this constitutes a 20-year period of continuous work to conserve, restore, and protect all of California's wetlands. And you can see these targets in more detail on CNRA's Expanding Nature-Based Solutions webpage. Next slide, please. CARB and CNRA's next steps are to develop ways to track and assess progress towards these targets and the impact that those actions have on ecosystems and society. In terms of carbon impacts, the Natural and Working Lands Inventory will be the foundation upon which these calculations will be developed. Additionally, for future iterations of the scoping plan, these targets will inform scenarios that will be modeled and help the state refine our climate action strategy. And through this effort, adaptive management can take place and the state will be better situated to enhance the beneficial impacts that climate action in coastal wetlands will have. Next slide, please. However, again, just because we set these targets does not provide us all of the science, data, and models necessary to incorporate all of these lands or actions into the strategy towards carbon neutrality. To accomplish this, we must clearly identify the gaps that are preventing CARB and the state from being able to track and assess coastal wetland carbon stocks and fluxes and climate action in these systems. Identifying these gaps is the first step to developing a strategy for filling them and ultimately including all coastal wetlands in CARB's inventory and scoping plan, which then helps the state direct funding and resources towards climate action. For this reason, this report that we're talking about in this webinar, commissioned by OPC, should act as an example for all others that would like to include specific carbon pools or ecosystems in California's or any state's inventory and climate strategy. And CARB would like to thank OPC for initiating this work and Melissa for undertaking it. And OPC are indeed leaders in this who saw a need and instead of balking at the hurdles, instead decided to work with other state agencies and stakeholders to find solutions. And so CARB looks forward to utilizing this report to direct efforts towards to enhance the science, monitoring, and modeling of California's iconic coastal wetlands. Thanks.
Thank you, Adam. That was exactly the foundation I needed to segue into the report itself. This is the Blue Carbon Ecosystem, specifically Coastal Wetland Data and Model Assessment Report, authored by Dr. Ward, who's present with us today. As Adam mentioned, the goal of this report was to get at that first step of identifying the gaps. So this, we went ahead with this report to assess if and how coastal wetlands could be included in CARB's 2027 scoping plan. So the first step of this was to really identify data and model needs, and thereby identify gaps to prioritize where we direct our investment. So in this report, number one, we outline some definitions and frameworks that are used in California's carbon inventories and carbon target modeling, along with the criteria and data required for including novel ecosystems in the future, with a focus on blue carbon ecosystems. As Adam mentioned, the work that's been presented in this report should be applied to anything new that's being included in the future into the scoping plan. So for inclusion, the applied models need to meet several criteria to fit the state needs, such as scalability across the entire state, transparency, and complexity of the model that's being considered for inclusion. So here, what we've done is we identify existing data and models that can act as a foundation for inclusion of these ecosystems as an additional land type. And really the goal of this report is to, the aim is to bridge the gap between site-specific data collection, which we have a lot of along the state, existing models, and what's really required for these models to be applied statewide to statewide carbon targets and inventories. And this is really intended to act as a guide for stakeholders, for scientists, and for other state agency partners when considering model or inventory development, as well as investment prioritization for coastal wetlands. So the report outlines criteria for model development for any new land type to be included in the scoping plan. So the criteria are both quality criteria on the model itself and really practical criteria for the state to actually produce estimates continuously and reliably for any ecosystem under consideration. So there are 7 of these, and I'll go through these one by one. First one is that the models for target development should be scalable spatially across the state, generating statewide carbon estimates for the specific ecosystem and be temporally explicit. The second is that the model carbon dynamics must include carbon stocks, yes, and ideally would also include emissions and other relevant carbon fluxes. Third, the model outputs should aim to be regularly updated, ideally automated so that there's as little manual intervention needed, and to detect change over time and to track changes over time by multiple agencies and stakeholders. Fourth, models and reporting should be transparent and reproducible with publicly available and open source data and code wherever possible. And this is something that the state has prioritized. Fifth is that the data need to have a solid basis in reality. They need to be validated, ideally with error, accuracy, or uncertainty statistics. So we know that we have confidence in these data sets. And sixth, if there are competing models that exist for the same type of ecosystem, the preference should be given to those that are more mature, meaning that have larger bodies of literature available, that are more transparent and publicly accessible, that address priority questions that the state has, and that have an existing user base. So these are the criteria that are used when there are competing models that exist. And the last one is that the data should be curated, off the shelf, and thereby limiting the need for processing by state staff. So easy to use, simple models. So for tidal marshes specifically, there are several existing models that were evaluated against these criteria, and the ones meeting some, if not most of these criteria were highlighted in the report. And here's what the key findings from the report were. We considered several coastal wetland ecosystem models against the criteria outlined earlier, as I mentioned, including the Peppermint Dam, the SWIM MEM models, the Warmer models, the SubCalc, SEDCalc models, the Lucas model, and the Invest Blue Carbon model. And overall, what we observed was that currently there are really no models that meet all of the outlined criteria in a rigorous manner, but we did observe that models exist that can act as a foundation from which further development can be made to meet those criteria identified in the report. So two models, the Peppermint Dam and the SWIM MIM. The Peppermint Dam is the peatland ecosystem photosynthesis respiration and methane transport dual Arrhenius Michaelis-Menten model. And the SWIM is the coastal wetlands equilibrium model or the marsh equilibrium models. These are the two models, along with future models that would potentially integrate these two models, are the most likely candidates for further development. These were the closest to meeting CARB criteria, and including these two models being predictive and forward-looking models. So when it comes to modeling, we identified several areas of investments that are needed to make sure that we get to where we want to be for the 2027 scoping plan. Number one is scaling these models for statewide application will require significant investment in reliable, high-quality mapping and appropriate validation of the models across the representative sites. We talked about tracking changes over time, and the maps need to be amenable to be able to track those changes so we can measure acre changes over time, condition changes over time, and status changes over time. So as of now, these data do not yet exist in a cohesive manner that can be used to fit the needs of the scoping plan. And the second investment priority is that there's really no single database that exists to track restoration projects, what their successes have been, what are the costs, and monitoring needs of these projects have been. So additional investment to address key gaps for tidal wetlands includes synthesis of all the location and success rates of restoration projects and monitoring of ongoing restoration projects to really track that outcome and inform future prioritization of resources. The third area of investment that was identified is that models to include additional blue carbon ecosystems like seagrass meadows or special estuaries with dynamic ocean inlets, heavily degraded wetlands, and other blue carbon ecosystems that have not been considered by these two models in the natural and working lands inventory and scoping plan. This could be ultimately developed based on the paradigm that we've developed, that we're trying to develop here for coastal wetlands. However, this will require significant investment in research to meet modeling needs and fill a lot of empirical data gaps that exist for these ecosystem types to enable a statewide application for these. So, management of blue carbon ecosystems, particularly a lot of time what we're dealing with is use and movement of sediment, can drastically alter associated carbon fluxes, as most of you are aware. So an improved understanding of these processes, how does movement of sediment affect these fluxes, and supported by robust models is going to be critical to elucidate carbon benefits gained in the coastal zone relative to other ecosystem types and management approaches. With that, I'd like to pause here and hand over to Adam, who will address next steps and identify gaps that exist. Adam, the floor is yours.
Great, thanks. Yeah, so because now with this report, we've set out this criteria, we've identified modeling and data gaps, both for inventory purposes and then also for scoping, primarily here for scoping and scoping plan and modeling efforts. Yeah, we kind of have a clear path forward on how we can work to incorporate as much coastal wetlands into our climate strategies as humanly possible. So first thing that we're doing is we're looking into developing or the development of methods to include coastal wetlands into the Natural and Working Lands inventory. So as I said, sort of at the top of my presentation, the first step to creating a climate strategy is understanding what you have and where it is and how it's changing. And that's our inventory. And so we are currently working on updating our natural and working lands inventory. And so here we're trying to expand coastal wetlands outside of the Delta into this inventory. So that's the first thing that we're working on. And I guess along with that, we're trying to address uncertainties in methods due to lack of mapping or empirical data or calibrated models. So that is to say, we're trying to think outside of the box on how we can address uncertainties that lie in carbon estimates, carbon flux estimates, carbon stock change estimates, given a paucity of data. So we're not going to go out. CARB is not in the business of going and collecting sediment core data or anything like that. So we have to work with what exists today, although we can, advocate for others to fund those sorts of research projects. But yeah, so we're looking at how can we use what's out there to fill some of our knowledge gaps with some level of scientific rigor, defensibility, and a reasonable amount of uncertainty. And then also, yeah, our next steps are taking these models that Shri had highlighted and seeing if we can scale those and implement them outside of the Delta to other coastal wetlands for specifically, first off, inventory purposes, and then later on for scoping plan model. So those are our next steps moving forward. So yeah, thanks, Shri.
Thank you, Adam. With that, we are ready to take questions now. Just a couple of things before we get started. If state agency staff could please refrain from commenting or asking questions at this time, please reach out to us after the meeting via email so that we are keeping this open for comments and questions from the public for now. Please email any written comments to my address, and I'll share this with the speakers and the stakeholders so get your comments addressed. So with that, I'm going to stop screen share and ask if Kyle is able to help us out with the question and answer session.
Hi, everyone. So we'll start with verbal questions before addressing any written questions. Just to make this as seamless as possible, to submit a verbal question, please use the raise hand function. If you're not familiar, you can find this function by pressing react and then raise hand. And I'll call on folks with raised hands. and open the floor for you to unmute and ask your question. Also to note, the chat function of Zoom, as you may know it, is disabled, but you may still submit written questions by pressing the Q&A button on your taskbar. With that, any questions? John Gallagher, I saw a reaction. I didn't see a hand raised though. If you'd like to submit a question, could you do one more thing?
I have a few questions that came to me via email a few days ago, and maybe I can bring those up, and Adam and Mel, if you guys can help address that, that'll be great. And then if there are no further questions from the general public, we can open it to state partners to see if they have additional questions. So the first question is, it came from Kevin Travis at OST, that he was interested in learning more about how CARB would integrate the report findings into the process for developing the 2027 scoping plan and the timeline for development at this point, if known at this point. I know, Adam, you touched on this earlier in the next steps, but so this may be helpful for the science community to have a sense of how and when science updates efforts such as this one can inform their process.
Yeah, great. Thanks. So, right, the next scoping plan will be adopted at the end of 2027, and the official scoping plan process is about 2 years. So I think officially scoping plan will kick off sometime next year. However, there's no reason to wait if Ocean Science Trust also wants to advocate for collection of data or development of models that will help us incorporate things into the scoping plan. Now would be the right time to do that. And so, yeah, looking at the report and seeing where those gaps are, and then trying to, get the information to fill those gaps will help us by the time the scoping plan actually kicks off sometime next year, probably. So, yeah.
Thank you, Adam. I think that's very helpful. And along similar lines, this is another question for Adam too. And the question was around how much in-house capacity does CARB have, and how the scientific community could be better involved in the process of model development.
Well, thankfully, the state has now, because we were able to include natural and working lands into our official equation for carbon neutrality and got it into the scoping plan in 2022. The state has now made considerable investments into our internal capacity for doing this work. So we have a whole new group of folks, Kyle here being one of those people that we've brought on. So we have several new modelers, remote sensing folks, ecologists to help us. That is, however, we can always use more help. I mean, the complexity of ecosystems and modeling and remote sensing and data is sort of endless. And so if scientists would like to help the state get more climate action done in these systems, my recommendation is typically come to us. And if you're going to submit a proposal for some new research or something like that, come to us like at the proposal development stage, and let's co-create something. So What typically is not usually successful is, just scientists on their own going and creating something and assuming they know what we need. But what is often successful is if we come in and we are partners in creating something that will actually meet our needs. And so that would be my recommendation for the academic community, or even NGOs, or whoever is going to take on some new research. Come to us. Let's co-create something. Get science, applicable to what we're doing here, and then get more climate action on the grid.
That's exciting news. Thank you, Adam. There was one last question from through email, is that there was a comment that all of this work dovetails really nicely with the state's priorities on mapping and tracking change. And they would like us to comment on how state agencies are dealing with mapping coastal ecosystems to enable tracking change. Maybe this question is like a question for both OPC and CARB, or I can address this first, and maybe Adam, you can add if something else, if you think of something else from CARB's end.
I was going to pass it to you anyway, so yeah, go ahead.
Okay, yeah, from OPC's end, definitely coastal mapping with tracking change of coastal habitat acreages and status tracking is a priority for OPC, and we've been investing in this area for the past several years. And more recently, OPC has initiated work on creating a group of expert panels for each of the coastal habitat type to figure out what this approach would look like for coastal wetlands, for beaches and dunes, for eelgrass, and for and rocky intertidal. So for the 4 of the different coastal habitat types. So the goal is that we do not have one cohesive approach across the entire state yet. So we want to figure out what are some of the ways that we can actually track change over time and not have to deal with a shifting baseline and have to deal with like a hybrid data set that is not super amenable to tracking change. So we're trying to come up with approaches that will help us track change, track status over time. And that's the way we're going to get to tracking the acreages. So we're working on this, and if you have any ideas or recommendations to help us further this effort, please reach out to me. I'm very happy to hear from you and collaborate if there's a path forward. So that's it for the questions from my end. Did anything else come up on chat, Kyle? If not, we can open it up for the audience in general, including our state partners.
Yeah, so we have John Gallagher who'd like to submit a verbal question. So John, feel free to unmute.
Hi, can you hear me?
We can hear you.
Oh, great. I tried to answer last time, but you didn't unmute me. Never mind. This is a form of subtle censorship. No, joking, sorry. No, I was just, it's mainly, I think, a question to Adam, because he's talking about data gaps and conceptual models. This has been my research for the last 10 years, not just measuring, which is important, but also the actual testing the blue carbon conceptual model. And I've been also working with Plan Vivo and Pure Earth on seaweeds and other things as well. So I'm pretty familiar with methodologies and what's going on, as well as assessing projects in the detail for carbon offsets. So I've got a good feeling of what is around and what has been understood. And wetland conceptual model in general, even the IPCC, which has some components which I've put in, does not fully grasp the complexity and all the possible services that blue carbon wetlands can deliver. And that's a problem, because the danger with these offset calculations, yes, I agree, it's good not to maximize and give a healthy system, but in the end, you've got to have a calculation of actually how much carbon is being removed or is mitigated. And this is not coming through, unfortunately. There's a lot of gaps which are put in the Q&A questions I've listed. I don't know if this is the forum to list them out now, but I encourage to read the preprint I've put in, which is a a summary of all the work I've been done, which is in review in Nature Communications at the moment. But the common ones is that carbon accumulation in the sediments is a measure of sequestration. That's the biggest fallacy at the moment, which is being perpetrated. And you must move away from that, because you can have lake systems which are known to accumulate carbon accumulation and increase their rate of carbon sourced by virtue of a lochthonous carbon being deposited and some of it also being remineralized. Even eddy covariance, which I said in this list, this one is not necessarily a gold standard. So what, for reasons of alkalinity and DIC export in tidal systems. So it's a very complex, and the science isn't settled. And I think Adam probably understands that more from what he said, but it's more unsettled than you think, not only in constraints, but also additional services which haven't yet been recognized. And particularly lochthonous carbon, again, which is labile and has been captured before it goes off to the ocean and then completely remineralized. This kind of service hasn't been taken into account. It's basically a more dynamic system than a terrestrial system, which doesn't have a great deal of exports and imports. And people are still thinking within that conceptual framework of red plus plus. It's like fitting a square peg in a round hole without knowing the hole is actually round at the moment. So that's all I have to say. And it's more of a sort of a promotion to what I'm trying to do in research. And hopefully if you read that preprint with all the references to previous stuff, maybe there's some indication of the conceptual gaps, not necessarily the data gaps, which involve that. All I have to say there. So I'm doing a bit of promotion on the nature of the conceptual model. That's all I have to say for now. And I hope you find it interesting and useful. Thank you very much.
Yeah, great. Thanks. Just a couple points I'd like to follow up on with that comment. So first, and this is like a common, I don't know, maybe misunderstanding of like what we're doing. So we aren't just focused on, we're not focused on offsets, right? That's not what we do. So we want to know the carbon dynamics everywhere, right? Not just within projects. That's not our objective. In fact, we're explicitly not quantifying project level carbon change. That's not the scale that we're thinking about. We're thinking about statewide. How are things changing? General directionality of carbon stocks and fluxes. So that's one thing, is just scale matters. And so we're not focused on project scale accounting. So that's just one little caveat. Additionally, the comment about, yeah, there's like a lot of complexity that these models don't address, and a lot of services that we can't quantify. That is not exclusive to wetland ecosystems, right? That's like every ecosystem, every model. We have that same challenge. Like I was saying, I think in my presentation, or maybe in one of my comments, ecosystems are infinitely complex, and there's no end to the modeling. It's never perfect, and you will never capture all the complexity. However, what we're trying to do is at least get, you know, something that gets us the general directionality of carbon stock change, fluxes, and general magnitudes of change. That's sort of the principle that we're focused on. Yeah, and of course there will be some also carbon dynamics that we're missing. Of course, lateral transfers of carbon that moves through the system. Wetlands are hard because, you know, carbon moves through these systems. That is an identified, already known, extremely tough challenge that we're thinking about. And so, yeah, there's that. And also that exists also in other ecosystems. There's lateral transfers in forests and actually everywhere. So anyway, just wanted to follow up on that. So yeah, back to you, Kyle.
Okay, the next question going in order, we have Bobby Hayden. Bobby Hayden wrote in and asked for Dr. Ward, what is one thing either covered or not yet covered that you'd like to underscore about your work?
Nice. Thanks, Bobby. Gosh, that is a very open-ended question. I mean, from the perspective of this report, I think it's been an interesting process in that I think for some number of years, the like blue carbon science and wetland community has been sort of shouting that we have lots of data and information and models. And that is and was true, but it was learning how to tailor all of that data and information and models to CARB's needs. And so I think there was like a number of back and forths for a long time about us saying we have data and CARB saying, well, we want to include it. And so this has been an iterative process to figure out how to get all the stuff that we do have into something that can be used by the state. And I think the dialogue and report produced has been like productive in evolving that conversation and like learning how we can best tailor all of that to work for the state and for wetlands and all those things. So that's like really high level, but I do just think that like, continuing to have the dialogue with OPC and CARB and CNRA and plugging stuff into the needs of the state and the models and the goals that we're setting is going to continue to be important, and we can tailor science better to do those things in the future and hopefully end up in a place that we want to end up. So I will also say that while we've done this for coastal wetlands like salt marshes and tidal wetlands, it's much harder for seagrasses and even harder for seaweeds, but it doesn't make them any less valuable. And so the minute you enter lower into the intertidal and subtidal, the like lateral exchange of carbon and the population dynamics, like a seagrass meadow can die in one location and pop up in another, and it's not visible from satellites. And so scaling to statewide becomes very difficult and requires like even more advanced thinking and models and remote sensing and all of these kinds of things. So I think we can use coastal wetlands to start and look at what we need to do on the path towards seagrass and then kelp forests, for example. So, you know, it's nice to have a vision for the future. And I think a lot of people, myself included, have learned what that process should look like now, and hopefully we can get there faster.
Right. And John, I see your hand. I just want to check with everyone here. Were there any other questions from the general audience? Okay. John, let me open it up for you to ask a second question.
Yes, thank you very much. I just want to come back on Adam. I appreciate what you say, Adam, in lots of ways, that you have to integrate the whole landscape, and that was part of the process and shows the complexity of all this. But I just want to just push back a little bit. The sort of things and issues I've been raising are not just theoretical, which obviously they are, but all backed by data sets being utilized in different ways. And many of the issues, unfortunately, it's for and against, so it's not a simple story, have large consequences by not including them on the estimate. You can turn, for example, a carbon sink into a carbon source, but by not including that one conceptual vector. So it's not fine-tuning of modeling, which I'm trying to push here, but actual large vector conceptual errors in not accounting or not including. Just going back to the previous speaker, which mentioned kelp forest, for example, I wrote a paper in 2022 based on data and thinking about it conceptually. That the classic paper by Kraus, Jensen, and Duarte, which spurred a lot of research, saying that 173 million tons of from seaweeds is sequestered to the bottom of the ocean. When we re-looked at the conceptual model to account for allochthonous carbon coming into the stuff and then taken up by the benthic fauna and so on by direct measurements, not by inferred measurements, which Kraus Jensen did, then a lot of seaweed systems, kelp systems, can be carbon sources, and a lot of the other ones are offset quite considerably. So when you redo their model, it changes from 173 million tons per year of carbon, not CO2, but carbon, to something to minus 54 on average. This is on average million tons per year. So these are not inconsequential sort of conceptual misunderstandings which have to be taken into account. I know it sounds all doom and gloom, but it's not always. But As you know, if you're overestimating, and it must be a conservative estimate in this, otherwise you get these unfortunate, if you do go into the carbon market, these perverse outcomes which allow large more emissions when the balance is actually not actually taken into account when you're restoring or whatever doing an ecosystem. So it's very important to not to yes, focus on the detail of measurement and large-scale measurements with satellites and proxies for carbon stocks. But if your fundamentals are not correct, it's counting the angels on the end of a pin, if I may say so. So that's all I have to say. And I really hope this gets through. Thanks so much.
Great, yeah.
Okay, with that, I think we have all the chat questions, and I don't see any more verbal questions in case we wanted to open it up to general audience. Oh, okay. So we do actually have one that just came up from Sylvia Troost. Oregon and Washington are not as far ahead as California, but are also interested in incorporating coastal habitats into their natural and working lands climate planning. Would there be interest and/or benefits in regional collaborations?
Thanks, Sylvia. Yes, you know, everything that we do, obviously we have a California focus. However, that's not where our objectives ultimately end. We want to do all of the hard work here in California where we have the capacity and will and political, you know, capital to do this work, but with the eye of helping other states, regions, countries sort of piggyback on our work. So yeah, for sure, there's definitely interest in that, and we actually do share a lot of this work through the U.S. Climate Alliance. Not every state's in that. Let me think. Washington for sure is, but Oregon I'm not so sure. So yeah, if we wanted to do a West Coast thing, we'd be interested in that.
I wanted to add something there too, Sylvia. You know, I'm from OPC. I'm part of the Pacific Northwest Blue Carbon Working Group. And that's another great place where we can enable these kind of collaborations and work together to kind of interest and like benefit from a regional collaboration structure that Adam talked about. Do any of our state partners have any questions? Great. It looks like we have no further open questions. With that, I really wanted to thank our panelists, Dr. Ward, Dr. Adam Moreno, and Dr. Lundberg for being here with us to help us support and run this webinar. This has been incredible work, collaboration between state agencies, scientists, and stakeholders. I'm so excited and honored to be part of this work. And thank you all for joining and for your interest in the space. Stay tuned. We have a lot of exciting work coming up because this is the first step in getting a lot of pieces moving towards 2027 scoping plan. Thank you, everybody, for joining, and we hope to stay in touch. Thanks. Bye.
Thanks.